Hello everyone and welcome to the last part of our topic on Strand 4.1. Please do watch this video until the end so that you are able to understand everything that I'm going to explain in this video, which also involves our practical component on test for ions. So we are going to see how we can do analytical chemistry, and at the same time we are able to identify the unknown ions which may be present in the solution. So when we are testing for ions, there are special chemicals which are called test reagents that are added to the unknown ion. Let's say you are doing a practical in the laboratory and you are given a sample of an unknown chemical. You are told that this chemical contains a positive ion and a negative ion, and you have to figure out what these ions are. So this explanation, this section will going to help you to identify what our missing solution would be. Okay, there are a few chemicals which are compatible with each other, which is why when we are reacting them, you should understand that the positive of one will always combine with the negative of the other and vice versa. Let's look at how we are going to test for the presence of carbonate ion. For this we need any dilute strong acid. Okay. After adding the strong diluted acid, we will see a fizzing gas coming out. Test the gas with lime water, and if it turns milky, we will be sure that it is carbon dioxide. That will be our confirmatory test for carbonate ion. This is the reaction that happens between the carbonate ion and the acid. So the carbonate ion reacts with the H plus to give you carbon dioxide and water. And the test for carbon dioxide is lime water, which will turn milky. Okay. Lime water is calcium hydroxide. The reason why it is turning milky is due to the formation of calcium carbonate, which is our precipitate. So let's watch this video to see how the carbonate ion can be tested in the lab.
Take a clean test tube.
Now add little amount of carbonate salt
with the help of a spatula.
And add few drops of dilute
HCl with filler.
Here we can observe the colorless fumes with brisk effervescence or evolving from the test tube. Now take
another test tube.
Add 1 ml of lime water.
Now pour this mixture into the lime water.
Observe here,
lime water turns to milky. This indicates that salt is having carbonate ion.
To confirm this again,
we have one more experiment.
Now take a clean test tube. Add carbonate salt and mix with distilled water.
Now add few drops of barium chloride solution. We can observe the white precipitate formation in the test tube.
This indicates
that salt contain carbonate ion.
The next anion that we are going to be looking at is chloride ion. Now to test for chloride ion, the test reagent that we use is silver nitrate solution. Now students, remember that in order for the identification to be made, the chloride ion, which is our negative anion, must combine with the positive ion from the test reagent. And in this case, the positive reagent or the positive ion is silver ion. So chloride ion will combine with the silver ion from the silver nitrate to give a white precipitate of silver chloride. And this silver chloride is an insoluble solid which will turn into violet when exposed to sunlight. So this is how the chemical reaction looks like. The silver ion coming from the silver nitrate reacting with the chloride ion, which is our unknown, to give a silver chloride precipitate. So you should write a small s that indicates a insoluble precipitate. Now let's watch a video to see how the white precipitate can be formed for chloride ion when it reacts with silver.
Solutions containing chloride ions are usually colorless. We can test for the presence of chloride ions. Solution
by using silver nitrate solution.
To a small volume
add an equal
of
amount
solution
of nitric acid.
add an equal amount of nitric acid.
If you have too much solution,
you may pour
leave
the
only a small
excess
volume
solution.
within your test tube.
Leave only a small volume within your test tube.
Proceed to add a few drops of silver nitrate solution. You will see that a white precipitate forms immediately.
Now we are going to see how sulfate ion can be tested in the lab. So again, when we are testing for sulfate ion, it must combine with a positive cation of the test reagent to form a particular precipitate. The test reagent to use for testing of sulfate is none other than barium chloride. And the ion that the sulfate is going to be combining with is barium ion. So this is how the barium ion and the sulfate will react together to give a white precipitate of barium sulfate.
Solutions containing sulfate ions are usually colorless.
test
We can test for the presence of sulfate ions by using
barium nitrate
barium
solution.
nitrate solution.
For a small volume of
For a
the
small
solution,
volume of your solution,
add an equal
add
amount
an equal amount
of dilute nitric
of
acid.
dilute nitric acid.
If you find yourself with excess solution, pour off the excess.
If you find yourself
and
with
leave only
excess
a small
solution,
volume within
pour
your
off
test
the
tube.
excess and leave only a small volume within your test tube.
Proceed to add a few drops of barium nitrate.
Proceed to add a few drops of barium nitrate.
You will see that a white precipitate forms immediately.
You will see that a white precipitate forms immediately.
Now that we have seen how anions can be tested in the lab, let's see how we can distinguish the cations from each other. And the first cation that we are going to be looking at is ferrous ion. For all the cations, we will use one test reagent, which is sodium hydroxide. Sometimes as a backup, we also add a little bit of ammonia to the test reagent as well. So let's see how we are going to add sodium hydroxide as a test reagent to identify the presence of ferrous ion. So since ferrous ion is our unknown solution which contains a positive cation, it will react with a negative anion from the sodium hydroxide to give ferrous hydroxide, which is a green precipitate. Now this green precipitate will be insoluble when you add extra sodium hydroxide. So when you are learning about the difference between the cation test, you must know what is the formation of the precipitate, what color precipitate is going to form when a little bit of sodium hydroxide is added and when excess sodium hydroxide is added. So let's watch this video to see how the laboratory identification is done for ferrous ion.
Solutions containing iron to ion.
Solutions containing iron to ion are typically pale green in
Compare
color.
this iron to sulfate solution.
Compare this iron to
Colorless
sulfate solution
like that of
to a colorless
aluminum
solution
chloride.
like that of aluminum chloride.
First off, we may use the sodium
First off,
hydroxide test.
we may use the sodium hydroxide test to test for the presence of iron to ions.
Hydroxide solution.
To a small sample of the solution, add a few drops of sodium hydroxide solution.
You will notice that a dirty green precipitate forms immediately.
You will notice that a dirty green precipitate forms immediately.
Proceed to add an excess of sodium hydroxide solution.
Proceed to add an excess of sodium hydroxide solution.
You will notice that the green precipitate remains insoluble in excess sodium hydroxide.
You will notice that the dirty green precipitate remains insoluble in excess sodium hydroxide.
You may also use ammonia to test for the presence of iron to ion.
You may also use ammonia to test for the presence of iron to
For a small
ion.
sample of this solution, add a few drops of ammonia solution.
To a small sample of the solution, add a few drops of ammonia solution.
Notice that a green precipitate forms.
Notice that a green precipitate forms.
Shaking the test tube can sometimes give a false impression that the green precipitate dissolves in solution.
Shaking the test tube may sometimes
What
give
actually
a false
happens
impression
is that the green
that the green precipitate dissolves in solution.
throughout the solution.
What actually happens is that the green precipitate is dispersed into finer particles throughout the
To
solution.
obtain a clearer result, continue to add excess ammonia.
To obtain a clearer result, continue to add excess ammonia.
Result is clear. The green precipitate remains insoluble in excess ammonia.
Result is clear. The green precipitate remains insoluble in excess ammonia.
The next ion that we will be looking at is ferric ion, which is Fe3+. Again, to test it, we are going to add sodium hydroxide solution to find out what is the color of the precipitate. Now, since ferric ion is a positive ion, it is going to combine with the negative OH- to produce ferric hydroxide, which is going to be orange in color. You can also test the presence of ferric ion using ammonia solution. Add a little bit of the test reagent to see the formation of the precipitate, and then you add excess to see whether the precipitate is going to dissolve or no. So let's watch this video to see how the precipitate is going to form. But before that, the other test that we will be looking at for the presence of Fe3+ is a solution called thiocyanate. Thiocyanate is an anion which can be combined with potassium to form potassium thiocyanate or ammonium thiocyanate. When this is added to the Fe3+, it will result in a dark red solution. And this is how the dark red solution is going to look like.
Solutions containing iron 3 ions are typically red brown, orange, or yellow in color, depending on the concentration of iron 3 ions. To test for the presence of iron 3 ions, we may employ the sodium hydroxide test. To a small sample of the solution, add a few drops of sodium hydroxide. You will notice that a reddish-brown precipitate forms. Proceed to add excess sodium hydroxide solution. Notice that the reddish-brown precipitate remains insoluble in excess sodium hydroxide. Next up, we have the ammonia test. To a small sample of the solution, add a few drops of ammonia solution. Notice that a reddish-brown precipitate forms immediately. Proceed to add an excess of ammonia solution into your test tube. Shake the test tube to ensure it holds mixing. Notice that the reddish-brown precipitate remains insoluble in excess ammonia.
Next up we have Cupric Ion, which is Ca2+, that's blue in color. Adding sodium hydroxide is going to result in a blue precipitate of copper hydroxide. Adding more sodium hydroxide will lead to the precipitate being insoluble still. However, you can still do a second test to confirm the presence of the copper ion by adding ammonia solution to that. So upon adding ammonia to cupric ion, it will result first in a light blue precipitate formation. Adding extra ammonia will result in a deep blue complex of ammonia forming up. This deep blue complex is known as tetraamine copper ion. It's a complex ion, that means the ions are written as in brackets. Okay, so all the ions, complex ion is basic, and in this case the ligand is NH3. A ligand is any chemical which contains lone pair of electrons or a negative charge ion. So whenever you have a metal ion combined with a ligand, that is a complex ion. And complex ion, as I said before, must be written in square braces. So this is a complex ion which is deep blue in color, that is formed when excess ammonia is added to the copper 2 ion.
Solutions containing copper 2 ions are usually blue in color. Test for copper 2 ion.
Solutions containing
One of the
copper 2
tests
ions
we
are
can use
usually
is the sodium hydroxide test. Sodium hydroxide.
Test for copper 2 ions. One of the tests we can use is the sodium
We'll notice
hydroxide test.
blue precipitate form.
To a small sample of your solution, add a few drops of sodium hydroxide.
Next, add an excess of sodium hydroxide.
You will notice the blue precipitate forms immediately.
Shake the test tube to ensure thorough mixing.
Next, add an excess of sodium hydroxide.
You will notice the blue precipitate remains insoluble in excess sodium hydroxide.
Mixing. You will notice the blue precipitate remains insoluble in excess sodium hydroxide.
Another test you can use is the ammonia test. To a small sample of the solution, add a few drops of ammonia solution.
Another test you can use is the ammonia test.
You will notice
To a small sample of the solution,
forms immediately.
add a few drops of ammonia solution. You will notice a light blue precipitate forms immediately.
To the light blue precipitate, add an excess of ammonia solution. You will notice that some of the light blue precipitate starts to dissolve to give a deep blue
To the
solution.
light blue precipitate, add an excess of ammonia solution.
To ensure thorough mixing.
You will notice that some of the light blue precipitate starts to dissolve to give a deep blue solution. Give the test tube a good shake to ensure thorough mixing.
Sometimes you may find that there's too much precipitate for it to dissolve entirely. If this happens, you may pour some of the solution and leave only some of the blue precipitate behind.
Sometimes you may find that there's too much precipitate for you to dissolve entirely.
By adding
If this
excess of
happens,
solution,
you may pour off some of the solution
and
leave only some of the blue precipitate behind.
This time you will see very clearly that the light blue precipitate dissolves.
Then, repeat
Produce a deep
by
blue
adding
solution.
excess ammonia solution to the blue precipitate. This time you will see very clearly that the light blue precipitate dissolves. Produce a deep blue solution.
Next, we look at silver ion and how we can test for silver ion using sodium hydroxide solution. Upon adding sodium hydroxide solution, we will end up forming silver oxide, which is a brown precipitate that doesn't dissolve when excess sodium hydroxide is added. Upon the addition of ammonia, a brown precipitate will again form, but this precipitate is going to dissolve when excess ammonia is added. Lastly, we have two more cations that need to be tested using sodium hydroxide solution. Unlike the other cations we have studied like Fe3+, Fe2+, Cu2+, and even silver ion, these two precipitate, which is magnesium ion and aluminium ion, will result in the formation of a white precipitate. So if it is white precipitate for both of them, it will be very difficult to identify which one is which. Therefore, we will see how you can run simultaneous tests to distinguish the two. First, adding a little bit of sodium hydroxide to both the solutions will result in the following reaction. Magnesium ion will combine with the hydroxide to form magnesium hydroxide, while aluminium ion will combine with the hydroxide to form aluminium hydroxide, both of which will result in a white precipitate. So, as a confirmatory test, we are going to add excess sodium hydroxide. When excess sodium hydroxide is added to magnesium ion, the precipitate of magnesium hydroxide remains. It doesn't dissolve up. But when excess sodium hydroxide is added to aluminium hydroxide, the precipitate is going to dissolve. So that is one way we can identify and distinguish the two different chemicals from each other. So let's see how we can test for magnesium ion in this particular experiment.
Take a test tube. Now add little amount of magnesium salt. Now add cold distilled water. Shake it well. This solution is called original solution. Take another test tube. Add few ml of original solution into it. Now with the help of filler, add ammonium hydroxide solution drop by drop to original solution. Observe here, the white precipitate is forming in the test tube. It indicates that the salt is having magnesium ions. We have another experiment to confirm it again. Take another test tube. Add few ml of original solution to it. Now add few drops of ammonium carbonate solution to original solution with the help of filler. Observe here, the white precipitate is slowly formed in the test tube. It indicates that salt contains magnesium ions.
Solutions containing aluminum ions are usually colorless. We can test for the presence of aluminum ions using the sodium hydroxide test.
To small sample the solution,
add a few drops of sodium hydroxide. Notice a white precipitate forms. Proceed to add excess sodium hydroxide.
Notice how the
white precipitate dissolves in an excess of sodium hydroxide. We may also use the ammonia test.
To small sample the solution,
add a few drops of ammonia solution.
Notice how
a white precipitate forms.
Proceed to add
an excess of ammonia solution. Notice how the white precipitate remains insoluble in excess ammonia.
There we have it. I hope you have learned a lot between how you can test the different ions, and that brings us to the end of Strand 4.1. So we have seen quite some interesting chemical inorganic reactions which involve our oxides, chlorides, chemistry of chlorine, test for ions, precipitation reactions, etc. We are going to commence on our Strand 4.2 in our next session. Until then, you take care, keep studying, keep revising your work, and bye!